The supervolcanoes that could trigger a new ice age. Did you know that some volcanic eruptions can release more energy than all the nuclear bombs on the planet combined? There is a scale that classifies these monstrous explosions from the quietest to the most apocalyptic. Today we're going to explore every level of this scale, from harmless lava flows to super eruptions that wipe out entire civilizations. We will explore the most potentially dangerous regions of the planet and the supervolcanoes we should be keeping an eye on. How close are we to the next big outburst? Keep watching to find out. Imagine a system that classifies the violence of volcanic eruptions as if it were a Richter scale for earthquakes, but focused on Earth's internal fury. That system exists and is called the Volcanic Explosivity Index, or VEI. This scale, created in 1982 by volcanologists Christopher Newhall and Stephen Self, allows eruptions to be classified according to their destructive power, ranging from VEI0 to VEI8. But what exactly is this scale based on? The VEI mainly measures the volume of material ejected during an eruption, including ash, humus, and volcanic gases, the height of the eruptive column, and the duration of the eruptive event. The more material the volcano ejects, the higher the VEI number. It is also taken into account if the eruption generates a column of ash that reaches the stratosphere or if it causes climate changes. In fact, at the highest levels, the VEI not only measures local destruction, but also its effects on a global scale. The VEI is a logarithmic scale. This means that each increase in a number represents an eruption 10 times more potent than the previous one. So, a VEI4 eruption is not a little stronger than a VEI3. It is 10 times more powerful. And a VEI6 is 1,000 times more destructive than a VEI3. The scale begins with a VEI0, which represents non-explosive eruptions, typically Hawaiian type, such as those of Mauna Loa in Hawaii, where lava flows calmly like a hot river. These eruptions eject less than 10,000 cubic meters of material, and their eruptive column barely reaches a few hundred feet. The next level, VEI1, includes mild, slightly more explosive eruptions that eject up to 1 million cubic meters of material and raise their ash plume to a mile high. Although they are not deadly, they can be pretty disruptive if they occur near populated areas. At the other extreme, we have VEI8, a category reserved for the most catastrophic supereruptions in geological history. To reach this level, the volcano must eject more than 240 cubic miles of volcanic material, an amount so gigantic that it can alter the global climate for decades or ages and cause mass extinctions. Only a few eruptions in the last few million years have reached this level. The more recent occurrence took place approximately 26,000 years ago in New Zealand near Lake Taupo. The use of VEI is not only academic or scientific. This scale is critical for assessing risks, establishing emergency protocols, and understanding the potential impact of an active volcano. For example, knowing that an eruption is VEI5, governments can anticipate disruptions to flights, the evacuation of urban areas, and the effects on agriculture due to ash. Despite its usefulness, the VEI has limitations. It does not accurately measure the thermal energy released or the chemical composition of materials. In addition, some underwater eruptions can have tremendous power. Still, because they do not form large columns of ash, they are classified as low VEI, although their effects can be devastating. While it's not perfect, for now the Volcanic Explosivity Index is our best tool for putting a number on the planet's fury. And as we move up this scale, each number represents a leap in destruction. Now that you understand how it works, get ready, because we're going to explore concrete examples of each level, starting with the lowest. VEI0, VEI1, and VEI2 eruptions. Let's start from the base of the scale, VEI0, the lowest level of volcanic explosivity. These eruptions are so quiet that you could be a few miles away from them and feel more fascinated than scared. A notable example is found in Hawaii with the massive Mauna Loa. Has had eruptions the last weeks or months, but they do not generate large explosions or ash columns. The lava simply gushes out and flows like an incandescent river. In 2022, Mauna Loa woke up after nearly 40 years and released a lava flow that traveled several miles, but without causing catastrophic damage. That is why it is classified as VEI0. less than 10,000 cubic meters of ejected material, and no significant eruptive column. Let's move on to VEI1, where volcanic activity is already starting to show a little more strength. These eruptions are still considered small, but they can spew ash and volcanic fragments to heights of up to 1.2 miles. A recent example is the moderate activity of the Stromboli Volcano in Italy. Known for its near-continuous eruptions, Stromboli releases small explosions of gases and volcanic material every few minutes, earning it the nickname the Lighthouse of the Mediterranean. Although not usually lethal, these explosions can pose a risk to hikers or island dwellers if they get too close. Another interesting case of VE1 occurred at the Kilauea Volcano, also in Hawaii. Although many of its eruptions are VEI0, some have reached the VEI1 level when the internal pressure increases and generates small explosions, ejecting fragments of molten rock over greater distances. Let's go up another step, and we reach VEI2, where things become more serious. These types of eruptions can spew up to 10 million cubic meters of volcanic material, and ash plumes can reach more than 3 miles in height. Here is a classic example: Mount Etna, located in Sicily. This European giant is one of the most active volcanoes in the world and has experienced numerous eruptions of VEI2 type. In 2021, one of its eruptions spewed plumes of ash that reached 6 kilometers high, disrupting flights and covering nearby cities with a thin layer of ash. Another notable case occurred in Iceland at the Eyjafjallajökull volcano, whose name means Glacier of the Island's Mountains. The first volcanic phase in 2010 of this volcano was classified as VEI2 before increasing in intensity. Although this initial eruption was not particularly violent, it was enough to alert experts due to its proximity to glaciers, which posed risks of flash floods known as yokullaps. And we cannot leave out the La Soufriere volcano in St. Vincent and the Grenadines, whose eruption in April of 1979 was of the VEI2 type. Although there were no fatalities, more than 20,000 people were evacuated, and the economic and social effects were significant. As you can see, while the VEI0 and VEI1 levels seem harmless at first glance, the VEI2 already represents considerable destructive power. These eruptions can disrupt flights, impact the respiratory health of people nearby, and significantly alter the local landscape. And the most interesting thing is that although we are still at the bottom of the scale, we are already beginning to see how the Earth can make itself noticed. But this is just the beginning. The most impressive is yet to come. VEI3, VEI4, and VEI5 eruptions. In VEI3, eruptions become noticeably more dangerous. We are talking about events that expel between 10 and 100 million cubic meters of volcanic material, and their eruptive columns can reach between 3 and 9 miles in height. It is no longer about explosions that only affect the crater. These eruptions can wipe out villages, cover entire cities in ash, and generate pyroclastic flows that kill everything in their path. A clear example is the Soufriere Hills volcano on the island of Montserrat. In 1995, this volcano awoke after centuries of dormancy and began a series of eruptions that intensified in 1997 with a VEI3 explosion. The capital city, Plymouth, was buried under a thick layer of ash and lava. 60% of the island was evacuated, and the population never fully recovered. The volcano is still active, and today more than half of Montserrat remains uninhabited, turned into an exclusion zone. Fast forward to VEI4, the tipping point where eruptions are already considered regionally catastrophic. These eject between 100 million and 1 trillion cubic meters of material, and the eruptive column can exceed 15 miles in height. Here, we enter the realm of events that disrupt international air traffic and temporarily alter the weather. One of the most documented examples is the eruption of the Galunggung volcano in Indonesia in 1982. Like the eruption of the Eyjafjallajökull volcano in Iceland, this VEI4 event also caused global air chaos, including an incident where a Boeing 747 flying through an ash cloud lost power to all its engines. Fortunately, it managed to land without casualties, but it was a red flag for the aviation industry. And now we come to VEI5, where eruptions officially fall into the category of disasters of continental scope. These eruptions eject up to 10 trillion cubic meters of material and launch eruptive columns that easily exceed 15 or even 20 miles in height. The most recent and spectacular example was the eruption of the Hunga High Pi volcano in January of 2022. This underwater eruption released energy equivalent to more than 100 atomic bombs from Hiroshima. Its blast wave circled the globe several times, and the ash plume reached 35 miles high, the highest point ever recorded by an eruption in the modern era. The eruption of Tonga caused tsunamis, communication blackouts for weeks, and affected the atmosphere globally. Despite its remote location, the effects reached as far as America and Asia. This reminds us that it doesn't take a super eruption to wreak havoc on the planet. A VEI5 can be enough to upset the planet's balance for months or even years. Another historical case of VEI5 was the eruption of Mount Vesuvius in 79 AD, which buried the cities of Pompeii and Herculaneum under meters of ash and pumice. Although the VEI system did not exist at the time, modern analyses placed this eruption in the VEI category due to the amount of ejected material and the regional impact. As you can see, at these levels, the Earth stops simply showing its strength and begins to modify the course of human history actively. And yet, we are not there yet. Hey guys, just a moment before we continue. Don't forget to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. VEI6 and VEI7 eruptions. We are entering the VEI6 level, the threshold where eruptions not only impact geography, but transform the global climate for years. This type of eruption ejects between 10 and 100 trillion cubic meters of volcanic material, and its eruptive column can reach up to 25 miles in height. They are so powerful that they can cause volcanic winters, mass famines, and the collapse of entire civilizations. One of the most famous cases is the eruption of Mount Pinatubo in the Philippines in 1991. This VEI6 eruption released more than 20 million tons of sulfur dioxide into the stratosphere, forming aerosols that reflected sunlight and cooled the planet. It is estimated that the global temperature dropped by about 1 degree Fahrenheit over the next 2 years. The eruption killed more than 800 people, mainly from pyroclastic flows, roof collapses from ash, and subsequent illnesses in shelters. But even that was moderate compared to what was to come. Another VEI6 event occurred in 1883 with the legendary eruption of Krakatoa in Indonesia. This eruption was so colossal that the shockwave circled the globe 4 times. The explosions were heard more than 3,000 miles away and generated tsunamis of up to 120 feet that killed more than 36,000 people. The eruption darkened the sky for weeks and produced spectacular sunsets across the planet. Even inspiring works of art such as Edvard Munch's famous painting The Scream. Climate records indicate that the global temperature decreased by 1.2 to 1.5 degrees Fahrenheit over the following years. But if VEI6 is catastrophic, VEI7 is almost apocalyptic. Only a handful of these eruptions have occurred in the last 10,000 years, and all have had lasting effects on climate, agriculture, and human society. To reach this category, the volcano must eject more than 100 trillion cubic meters of material, enough to cover the United States with a layer of ash more than a foot thick. The most dramatic case is the eruption of the Tambora volcano in Indonesia in 1815. Considered the most powerful eruption in recorded history, this VEI7 event caused the direct death of more than 70,000 people, but its indirect effects were even worse. The enormous amount of ash and gases released into the atmosphere generated the famous Year Without a Summer of 1816. In that year, snowfall in mid-June and frost in July ruined harvests in Europe and North America, leading to mass famines, migrations, and one of the most severe agricultural crises of the 19th century. Tambora's eruption was so intense that it reduced global temperature by more than 3 degrees Fahrenheit for at least a year. The sky turned gray for months, rivers froze in midsummer, and there were records of famine as far away as China and Germany. Amid this darkness, a young writer named Mary Shelley, trapped by bad weather in Switzerland, wrote a story that would change literature forever, Frankenstein. That's how profound the impact of a VEI7 eruption can be. Another possible VEI7 case, although it is still debated whether it reached such a level, was the eruption of the Changbishan volcano on the border between China and North Korea around 946 AD. This eruption spewed ash as far as Japan and created the impressive crater of Lake Heaven. Historical records mention strange weather events, extreme cold and crop failures for years. Although it was not as documented as Tambora, its scale was large enough to change the history of the region. VEI7 eruptions represent the pinnacle of volcanic power that we have experienced as a civilization. These are events so rare that you can count them on the fingers of one hand, but their effects last for centuries. And although these events seem exceptional, we still have one more step to climb: the most catastrophic eruptions that can exist on this planet. VEI8 eruptions. Do they put the very existence of humanity at risk? An eruption classified as VEI8 represents the absolute apex of volcanic power. This type of event ejects more than 240 cubic miles of volcanic material, and the eruptive column can reach heights exceeding 30 miles, piercing the stratosphere and impacting the planet's climate for decades. These colossi are not mere volcanoes, they are supervolcanoes, geological monsters capable of changing the history of life on Earth. The most recent and devastating example was the eruption of the Taupo Supervolcano in New Zealand's North Island, which occurred about 26,500 years ago. This VEI eruption emptied the magma chamber beneath the lake and spewed incandescent material at supersonic speeds, leveling thousands of square miles in minutes. It is estimated that it ejected more than 300 cubic miles of material, affecting the atmosphere and leaving a layer of ash detectable throughout the southern hemisphere. Not only did the super eruption completely reshape New Zealand's landscape, but it likely had global climate effects, causing a temporary cooling of the planet. But Taupo was not the only one. One of the most studied supervolcanoes in the world is Yellowstone, located in the United States, but we will discuss this later. Another colossus was the Toba Supervolcano, located on the island of Sumatra, Indonesia. Its eruption, which occurred about 74,000 years ago, was so violent that many scientists believe it came close to annihilating humanity. The Toba bottleneck theory posits that the eruption reduced the world's human population to a few thousand individuals, prompting widespread migration and genetic restructuring within our species. This eruption released more than 670 cubic miles of volcanic material and produced a 60-mile-long crater, which is now Lake Toba. Global temperatures are believed to have dropped by 5 to 9 degrees Fahrenheit, leading to ice ages and the collapse of ecosystems worldwide. And we cannot fail to mention the eruption of La Garita in Colorado, approximately 28 million years ago. This is probably the most significant known eruption in Earth's history. Although there were no humans to witness it, geological footprints indicate that it ejected more than 1,200 cubic miles of material, creating the La Garita caldera. It was an explosion so massive that it likely affected the planet's climate for decades or even centuries. VEI8 super eruptions are extremely rare. They occur on average once every 50,000 to 100,000 years. Still, their impact is so brutal that if one were to occur in modern times, it could collapse entire civilizations, trigger resource wars, and drastically reduce the human population. It's no exaggeration to say that a single VEI8 event could be the beginning of the end for humanity as we know it. Although these eruptions seem like things from the distant past, the reality is that supervolcanoes are still active, breathing slowly under our feet. And while we can't predict when the next super eruption will occur, we know that it will one day. What happens during a supervolcano eruption? When a volcano erupts, it doesn't just spew lava and ash. What happens is a violent release of pressure accumulated over centuries or millennia in the Earth's subsoil. Boiling magma, toxic gases, and incandescent rocks are expelled with such enormous force that they can change entire landscapes in a matter of minutes. But this is just the beginning. In a typical volcanic eruption, classified between VEI3 and VEI5, the effects are usually limited to a few tenths of miles. However, when we talk about a VEI8 eruption, everything changes. This type of event does not affect a region, it affects the entire planet. During a super eruption, the magma chamber doesn't just eject lava, it collapses in on itself, forming what's known as a caldera, a giant depression in the ground that can be tens of miles across. The initial explosion releases not only magma but also an immense cloud of volcanic ash that can rise to 30 miles into the atmosphere, entering directly into the stratosphere. Once there, the ash and sulfuric gases form aerosols that reflect sunlight, and the global drop in temperature begins. This phenomenon is known as a volcanic winter. Sunlight is reduced, temperatures drop by 5 to 10 degrees Fahrenheit, the seasons are altered, and harvests begin to fail. Even a drop of just 2 degrees Fahrenheit can dramatically reduce food production on the planet. During this time, rainfall becomes acidic, skies remain opaque for months or even years, and food chains begin to collapse. Moreover, the effects are not only climatic. VEI8 eruptions generate pyroclastic flows that move at speeds of more than 300 miles per hour, sweeping away everything in their path. They also cause earthquakes, tsunamis if they occur near the sea, and massive emissions of carbon dioxide and sulfur dioxide, which can poison the air and water. And if the eruption occurs in a densely populated area, the consequences are incalculable. To get an idea of the magnitude, suffice it to say that a VEI8 eruption releases energy equivalent to hundreds of thousands of nuclear bombs and can spew more than 600 cubic miles of volcanic material into the atmosphere. This volume is enough to cover an entire country under several feet of ash. The most disturbing thing is that these eruptions are not a thing of the remote past. They have happened several times throughout Earth's geological history, and the magma chambers responsible for them still exist. They sleep under our feet, slowly but steadily accumulating pressure. And while humanity has never witnessed a super eruption, we have experienced the effects of minor eruptions that have led to global cooling, agricultural crises, and geopolitical shifts. What a VEI5 eruption can do on a continent, a VEI8 can replicate on a global scale, multiplied by 100. Now that we know what happens during a volcanic eruption and why a VEI8 poses an existential threat to civilization, the question we must ask ourselves is, could it happen again soon? And if so, which areas should we monitor? The Yellowstone Hot Spot. In the heart of Yellowstone National Park in the northwestern United States lies one of the greatest natural threats on the planet, the Yellowstone Supervolcano. Beneath its landscapes of geysers, hot springs, and fumaroles lies a colossal magma chamber that has exploded with catastrophic force in the past, and it could do it again. This supervolcano is unlike traditional mountains like Mount Fuji or Mount Etna. It's what geologists call a hotspot, a plume of magma that rises directly from the Earth's mantle, piercing the crust like a blowtorch under a sheet of steel. This plume has been fixed for millions of years, while the North American tectonic plate has been shifting over it. The result is a series of gigantic calderas, and the most recent is Yellowstone. Yellowstone's last major eruption occurred about 640,000 years ago, classifying itself as a VEI8 eruption. It ejected more than 600 cubic miles of volcanic material, formed the current caldera, 45 by 30 miles in diameter, and covered vast regions of what is now the U.S. Midwest under feet of ash. Geological evidence suggests that this eruption had a lasting impact on the world's climate, causing mass extinctions in the Americas. But Yellowstone has had other eruptions just as violent. One 1.3 million years ago, and another even older, 2.11 million years ago. Both were of the same order of magnitude. This suggests that the system has an eruptive pattern, albeit an irregular one, that we should be concerned about. Why is it so dangerous? Because Yellowstone is still active. Under the park is a gigantic magma chamber divided into two levels. The shallowest contains partially molten magma, the lower one completely fused. In total, the system could store enough magma to cover the entire United States with a layer of ash more than a foot thick. An eruption of Yellowstone today would not only instantly destroy a region the size of several states, but also cause widespread devastation. Its atmospheric effects would darken the planet, disrupt global air travel, cause a multi-year volcanic winter, and lead to widespread mass starvation. The economic, social, and geopolitical consequences would be incalculable. The good news is that there is no evidence of an imminent eruption. Yellowstone is one of the most closely watched volcanoes in the world. Its tremors, ground deformations, gas emissions, and even the activity of the geysers are monitored. But the bad news is that despite all this monitoring, scientists still can't accurately predict when an eruption will occur. Premonitory signs can appear months or even weeks in advance, or not show up at all. That's why, more than fear, Yellowstone should inspire respect in us. It's not a matter of alarm, but of being prepared. Understanding how the supervolcano operates is crucial to mitigating its destructive potential. Scientific surveillance cannot prevent the eruption, but it can give us time to prepare, and sometimes timing is everything. Now that we know the sleeping titan of America, it's time to turn to Europe, where another supervolcano, more discreet but just as disturbing, is beginning to show worrying signs. The Phlegraean Fields. A few kilometers from Naples, Italy, lies a region that at first glance seems peaceful. Green hills, small villages, and ancient ruins. But beneath that superficial calm hides one of the most active supervolcanoes in Europe, the Phlegraean Fields. Its name comes from the Greek phlegraeos, which means burning, and it is no coincidence. Unlike a cone-shaped volcano such as the nearby and feared Vesuvius, the Phlegraean Fields are a volcanic caldera more than 8 miles in diameter, made up of a series of craters and geothermal structures that extend even under the Tyrrhenian Sea. Its last major eruption, approximately 39,000 years ago, is considered the most powerful to occur in Europe in prehistoric times, and was potentially a VEI7 eruption, close to VEI8. That eruption spewed tens of cubic miles of ash, devastating southern Italy and sparking a volcanic winter that affected Europe's climate for decades. Some studies even suggest that this event may have contributed to the extinction of Neanderthals, weakening their population and accelerating their disappearance in the face of Homo sapiens. Currently, the Phlegraean Fields are considered one of the most dangerous supervolcanoes in the world, not only because of their destructive potential, but because they are located under one of the most densely populated urban areas in Europe. In the event of a major eruption, more than 500,000 people could be directly in the impact zone. Added to this is the proximity of Naples, a city with a metropolitan area of more than 3 million inhabitants. The volcanic system shows clear signs of activity. Since the 1950s, ground movements have been recorded in the area, a phenomenon known as bradyseism, where the ground rises or sinks several centimeters per year due to the movement of underground magma. In some areas, such as Pozzuoli, the streets have risen more than 10 feet in recent decades. Additionally, there is an increase in seismic activity. In 2023 alone, more than 1,000 micro-earthquakes were recorded, some of which were felt by the population. In October 2024, a series of earthquakes prompted preemptive evacuations and prompted the Italian government to increase the alert level. Why is this place so worrying? Because unlike Yellowstone, whose next eruption could be thousands of years away, the Phlegraean Fields are showing signs of steady build-up pressure, and the time frame for an eruption, while still unlikely, could be measured in decades, not millennia. Furthermore, the rapid urbanization of recent decades has rendered evacuation plans extremely challenging. Scientists at the Vesuvian Observatory, who monitor the area, have repeatedly warned that a sudden reactivation could leave millions of people with no way out. This supervolcano does not need a VEI8 eruption to cause a catastrophe. Even a VEI5 or VEI6 eruption would be devastating for all of Europe. And if it were to explode to higher levels, the consequences would be felt throughout the Northern Hemisphere. Just as Yellowstone represents the volcanic risk in North America, the Phlegraean Fields are the European mirror of that threat. And both remind us that the Earth, although it seems stable, keeps under its surface a fury that awakens cyclically. As scientists better understand the scale of volcanic power, they have also intensified monitoring of active supervolcanoes around the world. Today, global monitoring networks combine satellites, seismic stations, GPS sensors, and chemical analysis to detect the subtlest signs of an impending eruption. But despite these advances, the challenge remains enormous. A recent example of this surveillance occurred on the Greek island of Santorini in February 2025. This island, renowned for its idyllic landscapes, is the rim of an ancient volcanic caldera that erupted approximately 3,600 years ago, one of the most significant eruptions in human history. That eruption, possibly a VEI6 or VEI7, destroyed the Minoan civilization and altered the history of the Mediterranean. In early 2025, hundreds of micro-earthquakes shook Santorini for several weeks, triggering a scientific alert. Authorities, in an unprecedented move, decided to evacuate more than 11,000 people, fearing that the volcanic system could be reactivating. Simultaneously, the British research vessel RRS Discovery was deployed to conduct underwater seismological and geothermal studies. Its objective: to monitor changes in pressure and temperature in the caldera, looking for indications of magmatic rise or the formation of new volcanic domes under the sea. The case of Santorini is not isolated. Another important example is in Iceland, where the Askja volcano has shown a sudden increase in seismic activity and ground deformation since mid-2023. The system has been monitored by the Icelandic Meteorological Office in collaboration with European research centers due to its eruptive potential and proximity to international air routes. Through the use of drones, satellite imagery, and thermal sensors, scientists are building three-dimensional models of moving magma to anticipate potential eruptions. In Indonesia, a country with more than 130 active volcanoes, the Magma Indonesia program has been implemented, a real-time monitoring network that warns of ground deformations, changes in volcanic gas composition, and seismic activity. In January 2024, thanks to this system, a tragedy was avoided by evacuating more than 20,000 people in time in the vicinity of the Ibu volcano, whose VEI3 eruption was accurately anticipated. In the United States, the Yellowstone Volcano Observatory not only monitors Yellowstone but also coordinates with other geology centers to perform simulations of eruptive scenarios, post-eruption climate models, and tests of early warning systems that could be activated even if the signals appear within a short time frame. Internationally, artificial intelligence networks capable of analyzing large volumes of seismic and volcanic data are being developed to find patterns that humans might miss. These AIs are being trained to detect silent pre-eruptions, where there are no visible explosions, but magma moves eerily underground. What these efforts have in common is an awareness of an uncomfortable truth. We cannot prevent a supereruption, but we can anticipate it and mitigate its consequences if we act quickly and scientifically. Science is our best defense against natural phenomena that we cannot control, but we can understand. Global monitoring, oceanographic surveys, digital simulations, and preventive evacuations are just the beginning. As volcanoes awaken, so does our ability to read their signals. The Earth will always speak to us. The question is, will we be listening in time? Volcanoes not only built the continents, they've also redefined the course of life on Earth more than once. VEI8 supereruptions are not a distant threat. They are a natural part of the planet's pulse. The real question is not if it will happen again, but when, and whether we will be ready when the Earth decides to speak in full force. Will science be able to anticipate the subsequent big explosion? Let us know what you think in the comments, and be sure to check out our next video on the end screens. See you soon.